In the second half of 8.5, we're going to learn about more types of variation. So recall from the last lesson that direct variation meant y equals kx, which means that as x goes up, y is also going to go up. As x goes down, y is going to go down. If a varies directly as b and c, then a equals k times both b and c. Also recall from last lesson that inverse variation means that y equals k over x. So if a varies directly as b, we know that a equals k times b, but if a also varies inversely as c, then c goes underneath k. So number 1 was an example of joint variation. Number 2 was an example of combined variation. Joint variation is just direct variation, but with two variables at once. So if y varies jointly as x and z, then we would write y equals k x z. Remember that when you are asked to write the equation, you have to use the equation with k in it. When you are asked to solve for one of the variables, you can use a shortcut. The way you find the shortcut, take your equation with k in it and solve for k. So in this one, we'd have to divide by x and z to find that k equals y over xz. And that would be your shortcut equation. Y over xz equals y over xz. On number 3, suppose y varies jointly as x and z, and they ask you to find y. So they are not asking us to write an equation, so we can use the shortcut formula. Y over xz is going to equal another group of y over xz. Find y, so we don't know what y is. Find y when x equals -2, z equals 3. Now we're going to plug in the other group to the other side. Y equals 10 when x is 4 and z is 5. Okay, we can cross multiply. Y times 4 times 5 is 20y. -2 times 3 times 10 is -60. So y equals -3. On number 4, y varies jointly as x and z again, so we're going to use the same equation. This time we don't know what z is. Find z when x equals 2 and y equals 8. We know that on the other side, y equals 6 when x is 5 and z is 3. So I'm going to multiply this diagonal first. 2 times z times 6 is 12z. And then the other diagonal, 8 times 5 times 3. 40 times 3 is 120. So z equals 10. Okay, as I mentioned earlier, combined variation is direct and inverse variation combined into one problem. So the equation that we would use if we wanted to write an equation for combined variation would be y equals kx over z. And if you want to take a shortcut, let's say you don't need to write the equation, you just need to solve for one of the variables. The shortcut equation would just involve solving for k. So if I wanted to solve for k, I would have to multiply y by z and then divide by x. So my shortcut equation would be yz over x equals yz over x. Suppose y varies directly as x and y varies inversely as z. So we know that when it's direct, it goes underneath it, but when it's inversely, it goes next to it for the shortcut equation. Find y when x equals -2. So we don't know what y is. X is -2. Z is 3. If y equals 10, when x equals 4, and z equals 5. Okay, multiplying diagonally, we get y times 3 times 4 is 12y. -2 times 10 times 5 is -100. So y equals -100 over 12. Those are both divisible by 4. So y equals -25 over 3. Suppose y varies directly as x and y varies inversely as z. So I'm going to show the formula with k in it just in case that's the one that you memorize and you don't memorize the other one. So y varies directly as x. We know that that means y equals k times x. But y also varies inversely as z. So we know that to be y equals k over z. So the z goes underneath. So since we don't have to write the equation, we just have to solve for one of the letters, we can get rid of k by solving for k. So if I was solving for k, I would multiply y times z, and then I would divide by x. So my equation relating only the non-constants would be yz over x equals yz over x. Find x when y equals -2 and z equals 3. So we're going to leave the x part as just x. Y equals -2 when z equals 3. For the other side, we know that y equals 10. And be careful that you're plugging everything in to the correct spot. X equals 4, that goes underneath. Z equals 5. Okay, multiplying diagonally, and I like to start with the one that has the variable. X times 10 times 5 is 50x equals -2 times 3 times 4. -6 times 4 is -24. So we divide both sides by 50, and we get x equals -24 over 50 Those are both divisible by 2. So our final answer is negative 12 over 25. Okay, for the back side, you're going to want to take out a calculator. The volume of wood in a tree varies directly as the height h and inversely as the square of the girth g. So the volume v varies directly as the height h. That means that v equals k times h. But at the same time, it varies inversely as the square of the girth. So g squared would be on the bottom. They want us to solve for a height, which means they don't want the equation relating the trees. So we can use a shortcut, and we get there by solving for k. So to solve for k, vg squared divided by h would equal k. And so my shortcut would be that vg squared over h for one tree equals vg squared divided by h for another tree. So we're given that the volume of a tree is 144, so we plug that in for v. The height is 20, that gets plugged in for h. The girth is 1.5, which is squared. Okay, and now we plug in for the other tree. What is the height of a tree? So we don't know h. When the volume is 1,000, and the girth is 2, 2 gets squared. So I'm going to start with the diagonal that has the variable in it. 144 times 1.5 squared, only the 1.5 gets squared, is 324. Times h equals 20 times 1,000 times 2 squared. That equals 80,000. So now we're going to divide 80,000 by 324. We get 246.9. We're supposed to round to the nearest meter, so that is approximately 247 meters. The average number of phone calls per day between two cities has found to be jointly proportional to the populations of the cities. Okay, that makes sense. So, as the number of people in a city goes up, you would expect that there would be more phone calls between the two cities involved. But then it is inversely proportional to the square of the distance. So the further apart two cities are, then you would think that would cause the number of phone calls to go down between the two. Right. One issue that I see is that we don't have any variables, so we're going to need to assign those. The average number of phone calls, could call that P, but then we have to use populations later, so I'm going to call the average number of phone calls A. It is jointly proportional to the populations of the cities, so we have multiple. So I'm going to call those P1 and P2. And then we also need to talk about the square of the distance, so we'll call that D squared. Okay, so we know that A is jointly proportional to the populations, so A equals K times both P1 and P2, but it is inversely proportional to the square of the distance. And it looks like they are not asking for an equation. They just want us to solve for something later. So I'm going to solve for k, a times d squared, and then I would divide by p1 and p2. That's what k equals. So this equation here this shows the relationship between the average number of phone calls between two cities, the distance apart they are, and the populations of each. Okay, now we're going to plug in what they give us. The population of Los Angeles is about 18.55 million, so that's going to go for one of the populations. The population of San Diego is about 1.356 million, so we need to keep in mind that all these numbers are in millions. The distance between them is 120 miles, 120 squared. The average number of calls between the cities is about 31 million. Find the average number of calls, so we don't know what A is, between New York and LA if the population of New York is 8.406 and the distance is 2,462, which gets squared. Okay, we need the other population, which, since this involves New York and LA, we can plug in 18.55 again. So the first fraction involved LA and San Diego, so we plugged in those two populations underneath. The second set involves LA and New York, so underneath we need the populations of LA and New York. So LA gets used twice. Okay, so now we multiply, and I'm going to start with the diagonal that has the variable in it. 18.55 times 1.356 times 2462 squared is 15246 8350.1 A equals, now we're going to multiply the other diagonal, 31 times 120 squared times 8.406 times 18.55 is 690,7732.32. We divide by the number in front of A. We get 0.456 5388 966. But keep in mind that is in millions, so if we want to round to the nearest call, we need to multiply by a million. A million is 1 with 6 zeros after it, so if I multiply by a million, I get 456,538.8966, which rounds to 456,539 calls. And on part B, we are finding the distance between San Diego and New York. Okay, so I'm going to write this equation again. AD squared over P1 times P2. So we were just given that the number of calls between the two is 33,900, but let's remember that we've been using millions for everything. So we should plug in 33,900 in millions. So I'm going to divide that by a million. So that is 0.0339. We are solving for the distance between them. So we don't get confused, I'm going to make a note that this is San Diego and New York. Okay, the populations. We were given earlier that the population for San Diego is 1.356. Population for New York, we were told, was 8.406. Okay, they don't give us a pair of cities to relate it to, so we're going to have to use something we've already used. I think we'll use LA and San Diego. Okay, so we have to use a pair of cities that we know everything about. So do we know the average number of calls between those two? Yes, we do. So we were told that the average number of calls between these two was 31 million. We were told that the distance was 120 miles. We square that. Okay, population of LA, we were told 18.55. The population for San Diego, we're going to use again 1.356. Alright, let's multiply diagonally, starting with the one that has the variable 0.0339 times 18.55 times 1.356 is 0.85271382 d squared equals 31 times 120 squared times 1.356 times 8.406. So this equals 50803.06.47, which means d squared equals 5967191.279. We square root both sides. We find that the distance rounded to the nearest mile is 2,443 miles.